So hello everyone, and let's get quickly within one of the problem from Geeks for Geeks. It says search in a sorted matrix. Now we are provided a sorted matrix where each row is sorted, and post completion of first row, the second row first element is obviously greater than the end. So if you remove this array and combine all of the element row by row, it will be a sorted array, a one dimensional sorted array. Now we are asked to find an x within this array. One naive method, we can go ahead and traverse the entire matrix n into m, which is not very efficient solution by far. You know this because if it was not given to us. So what we do in such cases? Remember that if we remove this, we get an sorted array, and the very best thing to work upon sorted array or search upon sorted array is applying binary search. But here is a catch. Are we going ahead and combining this matrix or converting this matrix to an array? If we are doing that, we are again encountering the problem of n into m, but we don't want it to do this. So let's go ahead and show this matrix. First of all, this matrix would look something like 1 5 9 14 20 21, bear with me, 30 34 and 43. I'm taking the first example and we are asked to find 14. Now for the binary search, I'll go ahead and I'll check for one row, second row, third row. That is also not an efficient solution. Why? I'll tell you just now. Because if you closely observe, even the row itself or column itself are sorted. So 1 14 30, this is a sorted manner, and if it is sorted manner, why don't I apply binary search right upon it? So what I'm saying is apply binary search upon row and column, which will make our overall time complexity of log n into of log m. How we are going to achieve this? Good one. So we are going to check first row, that within this column the first element of the first row and the first element of the last row. So this is the first element by L R. Let's take it a dot length minus 1. We are working upon this, and obviously this is the regular pattern of our binary search, where we take L is less than or equal to R and we go ahead upon further operations. Okay, give me a minute. Now here, what are we going to do? We are computing mid is equal to L plus R minus L divided by 2, and if mid is found, there is one possibility that it is a row. First of all, let's acknowledge the fact that it is a row. Mid indicates a row, so target row is equal to A of mid. Now things are clear. Now the target row with this example is this. Why so? Because mid is equal to 1, as 0 plus 2 minus 1, 2 minus 0 by 2. The formula for mid. Okay, now things being clear, two things can happen, that if x is in target or not. So how to check if it is in target? Then target row of 0 should be less than or equal to x, and x is less than or equal to target row of length minus 1. So length of the target row is target dot length minus 1. Well, and if it is within x, so just we can go ahead and return arrays dot binary search of target row. I'm just entering target row because we know that x is right within the target row, or may not be, but x cannot be upside or downside anywhere. So I'm finding for x if it's greater than or equal to 0, because binary search gives us index. Now this is very sweet and simple solution, but let's address if it is not within a row. If okay, my bad. If we were asked about 34, so if it is not in the row, where then we need to check for left or right. In this situation, I'll just go ahead with, if x is even lesser than target row of 0, then that means we need to search on the left hand side, that is r is equal to mid minus 1, else you know the drill, l is equal to mid plus 1. Ultimately we go ahead and we return false, because till this point we didn't find any of the number. Let's run this. Okay, it says target row is missing, not bad. Let's submit this now, and it seems it is working for rest of the test cases. Hopefully it will work for all the test cases, and yeah, here it is. So the time complexity, as you know, this goes in the problem of log n into log m, and this was a part of a binary search. For more such binary search related videos, click the video on your right, and I'll see you in the next one.